All right. Good morning or afternoon, whenever you're watching this video. So this is going to be section 8.2. Some of you are watching this to review, and some of you are going to be watching this on an Ed Puzzle as part of class because I am away on a professional development. So you're going to hear me pause so people can enter their answers on Ed Puzzle, and some of you can just watch this video on Haiku that I will be posting as well. So, whichever one is more convenient for you is fine. All right, so let's get started with pre-class. So for numbers 1 and 2, you're going to state the domain and the range for these parabolas. And in number 3, you're going to explain how to translate this function. So for those of you on Ed Puzzle, go ahead and enter your answers for domain and range for number 1 and 2, and then write an explanation of how the graph would change, or the translation of the graph for number 3. And then once you come back to Ed Puzzle, I will give you the answers. All right, so for number 1, the domain here, since this is a parabola, we should remember that the domain is all real numbers. The range, so notice there is a k value. It opens up, so this is going to shift the parabola down 2 units and open up. So we have y is greater than or equal to -2. All right, for number 2, the domain, again, should be all real numbers. The range, it opens down and it gets shifted up 5 units. So my range should be y is less than or equal to 5. All right, for number 3, explain how the graph gets obtained. So what does this do? It moves it to the left 2 units and down 6. So you should have said that in a nice sentence and then compared it to the graph of x squared. All right, so for today's section, we're going to do graphing simple rational functions. So this is pretty cool. I really do like rational functions, and I think it's really neat because it ties in a lot of graphing we've been doing all year long. So if you notice on the next slide here, rational functions come in the form of a fraction, okay? F of x equals p of x over q of x. So it really is a fraction where we have p of x and q of x are both polynomials. Okay. Now the key is, remember, we can never ever divide by 0, so our denominator can never ever equal 0. Another interesting thing is this ties in together our first section because inverse variation is actually a special type of a rational function. Okay. And then we're going to show you this on the next slide. So here is the parent function for the simple rational function, or parent. Remember the basic graph. So the basic graph is f of x equals 1 over x, or y equals 1 over x. This is also known as a hyperbola, okay? We'll come back to that in chapter 9. Now the hyperbola has 2 symmetrical parts that are called the branches, and you'll hear me refer to that quite a bit. Okay, and again, it has a domain and it has a range. Now if we take a look at it, it's very simple. If you notice, in this parent function, it has a vertical asymptote at x equals 0. The function can never ever cross there, and that vertical asymptote occurs at x equals 0. So that means my domain will be all real numbers such that x cannot equal 0. A similar thing here happens with a horizontal asymptote, y equals 0. So that means my range is going to be all real numbers such that y cannot equal 0. So we can't touch it. And if you notice, our branches will just approach both of those asymptotes like we've already been discussing. So they approach them. And then what we are going to do is we're just going to pick points to figure out exactly how to draw it. So we picked, 4 points or 6 points, however many points we want to pick. And then we approach our asymptotes. Okay, so example 1, y equals 4 over x. So if you notice, this is very similar to our parent function. The only difference is there's a 4 instead of a 1. So the first thing I like to identify in the basic function without any h or any k is a vertical asymptote. Okay, so the vertical asymptote is going to occur whenever the denominator equals 0. So that's going to always happen when x equals 0. The second thing I notice is that there's going to be a horizontal asymptote at y equals 0. So we have the domain restriction, all real numbers, such that x cannot equal 0. Notice it comes directly from your vertical asymptote. And your range is going to be all real numbers, such that y cannot equal 0. Again, comes directly from your horizontal asymptote now. And then step 3, we're just going to pick points on either side of our vertical asymptote. So let's go ahead and graph vertical asymptote and horizontal asymptote. And I'm just going to pick some points. So we're going to pick points to the left of x equals 0. Here's x and here's y. All right, so let's pick -1, -2, and -4. And when I plug it into my function, I'm going to get -4, -2, and -1. And again, I do x and y. And on the right of x equals 0, I'm going to plug in 1, 2, and 4. Just because those are easy points. 4, 2, and 1 is what I get out when I plug them into my function. And I plot those points. So we have -1, -4. There's my point. I have -2, -2. There's my point. And I have -4, -1. There's my point. Connect the dots to make it look like a hyperbola. There's one branch. 1, 4, 2, 2, and then 4, 1. And again, we want to connect the dots to make it look like a hyperbola. And there is your rational function. And that's the basic. Okay. Now, what we can do is translate the basic function by adding in an h and a k. So again, remember the h and k does something very cool. The h is going to move my vertical asymptote left to right, and the k is going to move my vertical asymptote up or down. So that's my h, and that's my k. So your asymptotes become h equals h, x equals h, excuse me, and y equals k. That is step 1, draw your asymptotes. Step 2, plot points, and then step 3, draw your branches towards those asymptotes. So example 2, we're going to go through those steps, just like we have, okay? All right, so in step 1, we identify the asymptotes. So for our vertical asymptote, it's going to be x equals 1. That's your h. For your horizontal asymptote, it's going to be y equals 2. That's your k. Now, automatically, you know your domain is going to be all real numbers such that x cannot equal 1. And you automatically know your range, all real numbers such that y cannot equal 2. Okay. And then step 2, we're going to pick points. I like to graph my asymptotes. So here's x equals 1. Okay. And then here's y equals 2. All right. So we're going to pick to the left of x equals 1. And then we're going to pick to the right of x equals 1. And we just pick a few points here. So to the left of x equals 1, let's pick 0. When I plug 0 in, I calculate the number and I get 5. When I plug in -2, I get 3. Let's plug in 2, I get -1. And when I plug in 4, I get 1. So let's plot those points. -2, 3, 0, 5. I draw the hyperbola, the branch, to go towards those asymptotes. 2, -1, and then 4, 1. And I draw the hyperbola to go towards those asymptotes and through those points. And that's it. And there's step 3, by the way, if you're labeling steps. Okay. All right, so here are the guided practices. Now, on Edpuzzles, I'm going to ask you to find the vertical and horizontal asymptotes in the domain and ranges for each one of these. And then you're going to just have to go ahead and graph. And then I'm going to stop. The Edpuzzle will allow you to put those answers in. And then you'll come back and I'm going to show you the answers. Okay. So guided practice number 1. Step 1, your vertical asymptote is going to be x equals 0. Your horizontal asymptote is going to be y equals 0. Thus, the domain is all real numbers such that x cannot equal 0, and your range is all real numbers such that y cannot equal 0. And then step 2, we're going to pick points. So again, I like to go ahead and draw my asymptotes. So we want left of x equals 0, and we want right of x equals 0. Here's my x and my y. Here's my x and my y. Oops. All right. And I'm thinking what we're going to do is, let's pick some easy numbers here. So we're going to pick to the left of x equals, so let's pick -1, -2, -4. Let's pick 1, 2, and 4. All right. So if I plug in -1, I'm going to get 4. When I plug in -2, I get 2. When I plug in -4, I get 1. I'm going to get -4, I'm going to get -2, and I'm going to get -1. -1, 4 will be right there. -2, 2 will be right there. And then -4, 1 will be right there. I draw the parabola through those, the hyperbola through those. 1, -4 right there. 2, -2 right there. 4, -1 right there. Draw the hyperbola through those points and then towards my asymptotes. And that's it. Okay, number 2, again, at Puzzle People, you're going to be entering your vertical, horizontal asymptotes and your domain and range. All right, so for step 1, your vertical asymptote for this problem is going to be x equals 0. There is no h. Thus, the domain is all real numbers such that x cannot equal 0. Your horizontal asymptote, notice there is a k, so we have y equals -5. Thus, your range is all real numbers such that y cannot equal -5. Let's plot those asymptotes so we know what points to pick. Okay, so we want left of x equals 0, and we want right of x equals 0. So we have x and we have y. We have x and we have y. All right, so let's see what we picked here. I think I picked, on the right, I think I picked 4 and I got 3, and I picked 2 and I got 1. Oops, I'm sorry, I might have did that wrong. Let me fix it real quick. All right, so for this one, I think I picked on the left, -1, I got -13. -2, I got -9, and then -4, I got -7. Then I picked 1, and I got 3. I picked 2, I got -1, and I picked 4, and I got -3. Now, I'm not going to plot this first point because it's off the charts. So let's go -2, -9, and then -4, -7. And we know the general shape of a hyperbola goes through those points and towards those asymptotes. We got 1, 3. We've got 2, -1, and we've got 4, -3. We know the general shape goes towards those asymptotes, and we're good to go. And there is step 2, and then there is step 3. All right, example number 3. Again, at Puzzle People, you've got your horizontal and vertical asymptotes, domain and range to plug in. All right. So step 1, vertical asymptote is going to be at x equals 3. That's right there. So that means your domain is all real numbers such that x cannot equal 3. Your horizontal asymptote is going to be y equals 2. There's a k. So your range is all real numbers such that y cannot equal 2. All right, step 2, we're going to pick points, but I like to graph my asymptotes first. So I get an idea of what points to pick. So I want left of x equals 3, and I want right of x equals 3. X and y chart. All right, and then x and y chart. And I think I just picked 2 points, to be honest with you. So to the left, I picked 2 and I got 1. And then I picked 4 and I got 3 when I did this earlier. So 2, 1, because that was really tiny. And I know the general shape of a hyperbola. And then 4, 3, and I got that was really tiny. Okay. You can pick more points if you want. Okay. All right, next concept, we can have some more complicated functions. So a rational function of this form, y equals ax plus b over cx plus d, also has graphs that are hyperbolas. So to find the vertical asymptote, that is when we have the line x equals negative d over c. So basically, you just set the denominator equal to 0, and you solve for x. To find the horizontal asymptote, you just look at the ratio of the leading coefficients. That's a over c. Okay, and in the same process, you pick points and you plot your hyperbola. All right, so here is example number 3. So for the vertical asymptote, 2 methods. You can just set the denominator equal to 0. You get x equals negative 2, or remember the formula. For the horizontal asymptote here, you can divide 3 divided by 1, and that's just 3. So your domain is all real numbers such that x cannot equal negative 2. And your range, again, is all real numbers such that y cannot equal 3. I like to plot those asymptotes first. Okay, that's step 1. Step 2, we're going to pick points. So we have left of x equals negative 2, and we have right of x equals negative 2. We have x and we have y. We have x and we have y. All right, so negative 2. I picked negative 6 and I got 6. I picked negative 4 and I got 9. Got negative 1, I got negative 9, and I got 4 and I got 1. I hope those are right. All right, so negative 6, 6 looks to be right there. Negative 4, 9 looks to be right there. I know the general shape for hyperbola. Negative 1, negative 9 looks to be right there. 4, 1 looks to be right there. I know the general shape of a hyperbola. And there it is. And that is step 3. All right, example 4 is a word problem. So your long distance calling plan has a fixed monthly fee of $4.95 and costs 5 cents a minute. All right, so right off the bat, I'm seeing 4.95 plus 0.05 a minute, so let's call that M. So we're going to write an equation that gives you average cost C, so C equals, so here's my cost, 4.95 plus 0.05 M per minute. There it is. Per means divided by, right? All right, part B, we're going to go ahead and graph this function. We're probably going to graph that on the calculator, and then we're going to use that to estimate the cost. So I would just graph it on the calculator, and then I get my cost is going to get about 55 cents a minute. Okay, and what happens to the average cost per minute as the number of minutes increases? Well, it's going to approach your horizontal asymptote. So it's going to approach 5 cents. Okay. All right, let's try some guided practices here. All right, so guided practice number 4. Okay, so step 1 for the vertical asymptote, remember we just set the denominator equal to 0. That's how we get x equals negative 3. For the horizontal asymptote, we just do the ratio of the leading coefficients, which is 1. So again, the domain is going to be all real numbers such that x cannot equal negative 3. And the range is going to be all real numbers such that y cannot equal 1. I like to plot those asymptotes. All right, those are my asymptotes. And then again, I have left of x equals negative 3, and I have right of x equals negative 3, x and y coordinates, x and y coordinates. All right, so I picked negative 7, I got 2, I picked negative 5, I got 3, I picked negative 4, and I got 5. I picked -2, I got -3. I picked -1, I got -1. I picked 0, and I got 1. All right, plot those points. -7, 2, -5, 3, -4, 5. I know the general shape of a hyperbola. Connect the dots. -2, -3, -1, -1, 0, 1. I know the general shape of a hyperbola. Connect the dots. There you go. Guided practice number 5. Okay. All right, so same thing here. So we have step 1, the vertical asymptote is going to happen when the denominator 4x minus 3 equals 0. So we have x equals 3/4. The horizontal asymptote occurs when the ratio of the coefficients, 2/4, which is 1/2. So your domain is all real numbers such that x cannot equal 3/4. And then your range is going to be all real numbers such that y cannot equal 1/2. All right, so I plotted these points. It's going to be tough here to see. And then what I did was I just picked a few points for this problem. You can pick a lot of points. I think you get decimals. But the general idea is we're going to get something that looks like this on this function. So again, pick points and you got it. I just didn't do that for this problem. All right, example 6. All right, so step 1, the vertical asymptote is going to occur when the denominator equals 0. So solving, you get x equals -1. Horizontal asymptote occurs with the ratio of the leading coefficients, so you get 3. Your domain is all real numbers such that x cannot equal -1. And your range is all real numbers such that y cannot equal 3. Again, for this problem, I'm just getting a little tired here. It's late at night. I'm going to plot these rational asymptotes here. And then I just picked a few points, and I got it goes over here, and I got it goes over here. So again, you can pick more points to be specific. Don't forget to do that, x and y. But it should look something like that. Okay. And then don't forget to do your summary. What does the graph of a rational function look like? It looks like something with 2 branches, basically, that has been moved h and k units, right? So your h is here, and your k is here. And then you got 2 branches. There you go.